Today's topic is the law of sines. So, up until now, everything we've done has been built off of right triangles or triangles where we can use a reference angle and then build a right triangle off of that. So, what happens if we don't have right triangles? So, that's what we're going to do today. So, let's turn off the video and let's share the whiteboard. So, first thing, what does it mean when you have an oblique triangle? Oblique triangles have no right angles. So whenever you know it's oblique, it's not going to be a right triangle. That's all it means. So there's right triangles, there's oblique triangles. They're different. Now we talked about solving triangles before, where we find all the side lengths and all the angles. In order to solve a triangle, you need a certain number of pieces of information. Now there's six total with our three angles and our three side lengths. In order to solve a triangle, you need at least pieces of information. Now, what are those pieces of information? When we have a triangle, and I'll draw in here in a second. I want to make sure this is not an isosceles, it's not equilateral. It's going to be just a scaling triangle. Might be one of the other ones, but we don't want to guarantee that. Now, in order to do this, we have our three pieces of information. We have three sides, three angles. We need to find combinations of three of those. So we could have all of the angles. We have all the sides. We could have a side, an angle, and a side. Now, I want to be careful with this, that would be a side, oops, excuse me, the side, the angle, and then the side. So the angle has to be between those two sides. Similarly, we can do angle, side, angle. We're just looking at the blue, angle, side, angle, where the sides between the two angles. We could also do angle, angle, side. So for this one, we are still knowing two angles and a side, but it's going to be different than the last one we just did. Because this is going to give us angle, angle, side. Notice how the side is not between the two angles. Now we could also write this as side, angle, angle. They're interchangeable. We're getting the same information. Our last one is going to be side, side, angle. And again, it's going to be a side, and then the angle in that order. Please write it as side, side, angle, not angle, side, side. If you try and write it angle, side, side, I think you'll see why. All right, so we are going to see which of those are going to work for what we're going to do with the law of sine. But before we even do that, let's find out what the law of sine states. So let's draw our triangle again. And now, since we're used to drawing right triangles, let's make this have a right angle. And we'll call that height H. So we're drawing an altitude. Be careful that altitude will not bisect that bottom line, the C line of C. It will break it into two parts, but it does not necessarily break it into equal parts. So since it's law of sines, we are going to use sine. So let's look at our A. Angle A, sine of A, is going to be H, because that's opposite of it, over B. Looking on the other side, sine of B is going to be H over A. So let's solve both these triangles, or both these equations, for H, because that's our common value. So let's multiply by the B, multiply by the A. So B sine of A is the same as H, and A sine of B also equals H. So what we can do now is we can ignore that H. And now we have a nice equation with just our A's and B's. So let's get the A's and B's on the same side. Now there's two ways to do that. One, I could divide the A and the B over. So I would get this. And now by extension, if we would have drawn a different altitude, we can extend this correlation, this relationship, this equation, to include C's. But if we would have done it the other way, divided the sines over, we would get this. Let me make that look more like the word that looks like sine. And then again, by extension, we could have a different situation where we bring in our C's. Now, these two equations are the law of sines. If you like one of them, you can use it all the time. But if you are strategic, you can make your life a little bit easier. So we have to figure out which combinations of angles and sides we can use the law of sines. Now, if we're going to do this, we're going to not have all three of them. We're going to only do two at a time. So we're looking at a situation like this. And it doesn't matter which one we pick. But the thing is, we're going to need three of these pieces of information. So we either need two angles and a side, finding another side, or we need two sides and an angle, finding another angle. So that's going to be what we need in order to do our law of sines. So going back to our options, which of these does that apply to? This one doesn't, has all angles. This one has all sides, does not work. Now, this one does have two sides and an angle, but when we do the side angle side, it has parts from A, B, and C. What we need are two from A or two from B, or what I like to call a matching pair, a side and an angle of the same letter. We don't have that with side angle side. If we do angle side angle, we still don't have that matching pair. But since we know two angles, and this is Euclidean geometry, all of the angles in the triangle have to add the 180. So we can find angle C, then we will have the matching pair. Angle, angle, side. We have the matching pair of the A's, so that's good. And side, side angle, we also have that matching pair. So these three are going to be what we're going to look at. So let's go ahead and try a few of these examples.
if I can get it to slide where I need to slide to. All right. So first one, let's start with an angle, side setup. Now you could be given a triangle drawn or you could just be given the information. Let's start with just being given the information. So the measure of angle A is going to be 20 degrees. The measure of angle B is 75 degrees. And side A is going to be 10. So if you're not given the drawing, I always like to draw it out just to have a visual representation. It's a little easier to see things. That's 10. That's 20. That's 75. There's my B. There's my C. So the first thing that's easiest to find is let's find angle C. Since our angle is going to add 180, our A plus B are going to be 95. Subtracting that from 180, the measure of angle C is going to be 85 degrees. Next up, we can now either find side B or side C. Let's do side B. If we are strategic, let's use this equation for our law of sines. It doesn't matter which one we use, but this one has our unknown on top. So to get little side B by itself, we just have to multiply sine of B over. So that's going to make our life a whole lot easier. So B is going to equal 10 sine of B, which is 75, over sine of 20. Important thing to note here is you must be in degree mode on your calculator. And be careful with your parentheses. It turns out that B is roughly 28.241781114 units, whatever our units are. All right, let's do the same thing, but for C. C over sine of C is going to be A over sine of A. So again, same idea. All we have to do is multiply across. So that's sine of 85 degrees over sine of 20 degrees. And this is roughly 29.12678441 units. Now let's check to see if this makes sense. So there's something called the scaling inequality. Just writing that out. Now, what the scaling inequality says is that in a triangle, the smallest side will be across from the smallest angle, and the biggest side will be across from the biggest angle. Now, looking at what we have here, angle A is the smallest, and side A is the smallest. Angle C is the biggest, and side C is the biggest. So, smallest side across from the smallest angle, biggest side across from the biggest angle, and then middlest side across from the middlest angle, if you want to make up some words. All right, let's do another one. Let's do an angle side angle situation. So say we're given the drawing this time. X is 40 degrees. Y is 55 degrees. Z is up there. And is 15. There's X, there's Y. And let me make that look like a better Y. There we go. All right. So the first thing we have to find here is angle Z. That we need to know angle Z to have our matching pair in order to use our law of sines. So again, adding our angles together, our X and Y add the 95. So therefore, this is going to be 85. And no, the answer is not always 85 for that remaining angle. All right, so now we have our matching pair of Z's. Let's use that to find either X or Y. Let's find side X. And again, we're going to use the same equation we did before, just because we're finding a side length. So we went to a side length on top. Now, eventually, we're going to do sine of Y, or excuse me, Y over sine of Y equals Z over sine of Z. And then we're going to do the exact same thing. All right, so that's 15 sine of 40 divided by sine of 85. And that number gets us roughly 9.6743096 of whatever units we're using. And again, make sure you carry all those decimals, do not round. In this case, it's not going to make much difference because this is our final answer. But if you're ever going to use a value in another calculation, make sure you do not round. All right, let's try it again for Y. And we end up with 12.3342160,803. Make sure this 2 looks more like a 2. There we go. All right, so let's do our comparison with our scaling inequality. Z is our biggest angle at 85, and it's our biggest side length at 15. X is our smallest angle and our smallest side, and Y falls in the middle. All right, so the scaling inequality won't necessarily help you to guarantee that you are correct, but it can help you find mistakes. So if that scaling inequality is violated, you know you messed up, go back and fix your work. But just because it works out doesn't mean you're correct. So be careful on that. Now, there's more that we need to do, but we've gone pretty long with what we have now. So let's make a break with this and we'll finish up this uh, lesson and we'll pick up with the rest of it later on. But now we know how to handle certain situations where we have non-right triangles that we can use our law of sines for an angle side, an angle side angle, and we'll see how we use it for side angle. But we no longer need right triangles on this that are law of sines, and in words, we skip that part. It's that the ratio of the side lengths to the sine of the angle opposite of it are equal. That, sure, we have big sides and small sides. They correspond to big angles and small angles. But whenever we do the fractions, they're going to be the same. So the ratios of the side lengths to the sines of the opposite angles are equal. Or if you want to switch around, the ratios of the sines of the angles to the sides opposite are the same. So there's the intro to our law of sines. We'll finish it off on another lesson.